Hello everyone. Now let us solve some problems on the previous topic. In that first question, determine R equivalent across AB terminals for a network shown in below figure. This is the given circuit. Okay, this is 2 ohms. This 2 ohms and 2 ohms are connected in series. If two resistors are connected in series, what is the equivalent? Addition of two resistors. So this is 4 ohms. Here 2 ohms, 2 ohms, 2 ohms are connected in series. So this is equivalent is 6 ohms. Similarly, if 4 resistors are connected, 8 ohms. Up to this is 10 stages. So 10 stages means up to 20 ohms. So the circuit can be drawn as this is 2 ohms, this is 4 ohms, this is 6 ohms. Okay, this is R equivalent AB. So if resistors are connected in parallel, what is the equivalent resistance? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus and so on 1 by R10. So here what is R1? 2 ohms plus R2 is 4 ohms plus 1 by 6 ohms plus and so on plus 1 by 20. Okay, so if you solve these equations, you will get 1 by R equivalent is equal to 1.4644. So now I want to find out R equivalent. R equivalent is equal to 0.6828 ohms. Next question is determine L equivalent across AB terminals for network shown in the below figure. This is the given circuit. Whenever this type of questions are given, that means this type of circuits are given, first name all the nodes present in the circuit. Okay, first name all the nodes present in the circuit. Okay, this node is also A, so this node is also B. Let it be C, let it be D, E, F, G, H. Okay, if you observe here, this C, D, A are shorted. Okay, A, C, D. Okay, A, C, D are shorted. Shorted means all these nodes are at equipotential. A, C, D are at equipotential. Similarly, B, F, E are at equipotential. These three nodes are at equipotential. That means here and here and here we have same potential. Okay, so this is A, this is also A, this is also A. If you observe here, this inductor is connected across A and G, and this inductor is connected across A and G, and again this inductor is connected across A and G. For suppose this is A, this is G, so first inductor is connected across A and G, and second inductor is connected across A and G. Let it be A, let it be G. Third inductor is connected across A and G. So if you see this, all these three are in parallel. This is L, L, L. So what is the equivalent? 1 by L plus 1 by L plus 1 by L. You will get 3 by L. This is 1 by L is 1 by L equivalent is equal to 3 by L. So what is L equivalent? For this only. Okay, for this circuit only, L by 3. Similarly, same. So this inductor, so this is point B, that is node B, and this is also node B. From B to H, this is L inductor, and B to H, this is L inductor, and B to H, this is L inductor. So all these three are in parallel. So the equivalent inductance is L by 3. Okay, if you observe this, this inductor is connected at G. Okay, so this inductor is, the bottom inductor is connected at G. All these three are connected to G. So and top inductor is connected at A. So this point is A. Similarly, this point is B, and this point is H. Okay, this node is H. Now, this L by 3, L and L by 3 are in series. So, what is equivalent inductance? So, L by 3, addition of all the inductors. If inductors are connected in series, the equivalent inductance is addition of all the inductors. So, L by 3 plus L by 3. So, you will get 5L by 3. Okay, the circuit becomes like this. Now, this L and this 5L by 3 are in parallel. So, what is the equivalent? LAB is equal to, if two inductors are connected in parallel, what is the equivalent? L1 L2 by L1 plus L2. Okay, this is the formula for parallel inductors. Now, what is LAB? L into 5L by 3 divided by L plus 5L by 3. So, if you solve that above expression, you will get 5 by 8 L or 0.625 L. Next question. If CAB is equal to ACX plus BCY, then find the values of A and B. This is the given circuit. Similarly, if you observe here, let it be node some X or let it be node P. So, this is short circuited. So, this is also P. Okay. So, this is ground. This is ground. Now, in between A and P, CX is connected. In between A and P, CX is connected. Similarly, A and P, CY is connected. If, and here, B and P, if you observe B and P, from B to P, CY is connected. From B to P, CX is connected. Okay, the circuit can be modified as like this. Okay, see here. So, in between A and P, that means ground. This is node A. From A to ground, there is a CX. A to ground, there is a CX. Again, A to P, that means this is ground and it is short circuited. So, it is also ground. From A to ground, there is a CY. So, A to ground, there is a CY. From B to ground, this is ground. So, B to ground, there is CY. This is CY. And B to ground, there is CX. This is CX. Okay, here, these two capacitors are connected in parallel. If capacitors are connected in parallel, what is the equivalent? Summation of two capacitors. So, that is C equivalent. If two capacitors are connected in parallel, C equivalent is C1 plus C2. Okay, so here CX plus CY. Similarly, these two capacitors are connected in parallel. So, what is the equivalent? CX plus CY. So, the circuit becomes like this. Okay, now again, these two capacitors are connected in series. These two capacitors are connected in series. If capacitors are connected in series, what is equivalent? If two capacitors are connected in series, the equivalent capacitance is C1 C2 by C1 plus C2. Here C1 is CX plus CY. Again C2 is CX plus CY. So, C equivalent is equal to CX plus CY into CX plus CY divided by CX plus CY plus CX plus CY. So, C equivalent you will get 1 by 2 into Cx plus Cy. So, this is Cy, this is 1 by 2 into Cx plus Cy. This is A, this is B. These two capacitors are connected in parallel. So, what is the equivalent? CAB is equal to Cy plus 1 by 2 Cx plus 1 by 2 Cy. This can be written as 1 by 2 Cx plus, so 1 by 2 plus 1, 3 by 2 Cy. This compare with A Cx plus B Cy. So, what are the values of A and B? A is equal to 1 by 2, B is equal to 3 by 2. Let us discuss one small concept, that is, if two resistors are connected in parallel with same value, that means if the resistance value is R, let it be R, and this resistance value is R. What is the equivalent? R equivalent, if two resistors are connected in parallel, R equivalent is equal to R1 R2 by R1 plus R2, that is R into R by R plus R. So you are getting R by 2. That means if two resistors are connected in parallel with same value, the equivalent is by 2. For suppose if three resistors are connected in parallel, what is R equivalent? 1 by R equivalent is equal to 1 by R plus 1 by R plus 1 by R. That is all are equal. So 1 by R equivalent is equal to, here it is R. So 1 plus 1 plus 1. So what is R equivalent? R by 3. Similarly, if n resistors are connected in parallel, so what is R equivalent? R equivalent is equal to R by n. Same formula is applicable for L equivalent. If n inductors are connected in parallel with same inductance value, then L equivalent is L by n. Similarly, Z equivalent is equal to Z by n. That means n impedances are connected in parallel with same impedance, then Z equivalent is Z by n. Similarly, if capacitors are connected in series, okay, if resistors, inductors, impedances are connected in parallel, then equivalent is by n. If capacitors are connected in series, okay, capacitors must be in series, then what is C equivalent? C equivalent is C by n. From this discussion, what is the conclusion? If resistors are, inductors are, impedances are connected in parallel, equivalent impedance is decreases. Okay, equivalent impedance is decreases. Similarly, capacitors are connected in series, equivalent capacitance is decreases. In the next video, we will discuss some more problems. Okay, thank you for watching.